we have studied about the Newman and Sawhorse projections, and we have seen how to write the eclipsed and staggered conformations in these two projections. Now, we will discuss the relative stabilities of eclipsed and staggered conformations. So, we have seen that in eclipsed the groups are closest to each other, and in staggered the groups are farthest from each other. Okay. So, now we will discuss the relative stabilities. Relative stabilities of eclipsed and staggered conformations. Okay. So, in the eclipsed conformation, what happens? The groups are closest, right? If the groups are closest, then they will experience maximum repulsive force. Because see, in this eclipsed conformation, one hydrogen is here, another hydrogen is here. So, they are very close. So, they will experience repulsion from each other, due to which there will be maximum repulsive force, and we had already discussed that repulsive interaction leads to torsional strain. Okay. So, maximum repulsive force will lead to maximum torsional strain. We know that any kind of strain reduces the stability of a system. So, maximum strain means maximum energy, and we know that stable systems have lowest possible energy. So, this makes the system unstable, or we can say less stable. Okay. Now, what happens in case of staggered? In case of staggered, groups are farthest from each other. Like this is a staggered conformation. One hydrogen is here and another hydrogen is exactly opposite. So, these have very less repulsive force between them. Also, these hydrogens are also far away. So, staggered conformation has minimum repulsive force. So, of course, minimum torsional strain. So, minimum energy, and we know minimum energy means the stability will be high stability. So, according to the order of stability, staggered will have greater stability than eclipsed. Okay, so if staggered has greater stability than eclipsed, then we know that infinite conformations are possible. Staggered and eclipsed are not the only ones. So, any conformation between eclipsed and staggered, conformations between eclipsed and staggered are called skew. Okay. So, any conformation between eclipsed and staggered are called skew. So, this eclipsed and staggered conformations have an energy barrier of 1 to 20 kilojoule per mole. Now, this is a very low amount of energy. This energy barrier is quite easy to cross. That is why under the normal conditions, molecules gain enough thermal and kinetic energy to overcome this small energy barrier. That is why they undergo free rotation, and the rotation is so rapid that the different conformations are not possible to be isolated. So, till now we have not been able to isolate the different conformations of a molecule. So, we have discussed about the conformations and structural isomers of alkanes. Now, we will study about the preparation of alkanes, or how the alkanes are prepared from other type of compounds. So, we will start preparation of alkanes. Okay. So, what are the natural sources of alkanes? Petroleum and natural gas are the natural sources of alkane. Apart from these, we can also prepare alkanes in laboratory. Okay. So, there are some methods of preparing alkanes. Mostly alkanes are prepared by reduction of alkenes, alkynes, alkyl halides, aldehydes or ketones, we can say carbonyls, carboxylic acids, etc. Okay. So, alkanes are mostly prepared by the reduction of these group of compounds. So, what is reduction? So, basically we know addition of hydrogen is called reduction. Okay. Also, in organic chemistry, replacement of more electronegative atom with less electronegative atom or hydrogen is called reduction. Okay. So, there are some reducing agents. Now, reagents which carry out reduction. Okay. Reagents which carry out reduction are called reducing agents. Similarly, reagents which carry out oxidation are called oxidizing agents. Right. So, what are the different types of reducing agents? There are various common reducing agents. So, we will read some common reducing agents. Okay. So, one is hydrogen with metal catalyst. Generally, metal catalysts that are used are platinum, palladium, nickel, etc. Okay. Then zinc plus HCl. Zinc plus acetic acid. Zinc copper plus ethanol. Lithium aluminium hydride. This is a very strong reducing agent. Okay. Then sodium borohydride. These two reagents, lithium aluminium hydride and sodium borohydride, have similar mechanism for reduction, but sodium borohydride is a mild reducing agent, while LiAlH4 is very strong. Okay. So, these are some common reducing agents. So, the fast method for preparation of alkanes is preparation of alkanes. Okay. The fast method is from unsaturated hydrocarbons. That is alkenes, okay, alkenes and alkynes. Okay. Both of them, in the presence of hydrogen and metal catalyst, gives alkanes. Okay. Alkenes and alkynes in presence of hydrogen and metal catalyst give alkanes. This method is known as hydrogenation. Hydrogenation. Hydrogenation means addition of hydrogen. Addition of hydrogen. Okay. This is called hydrogenation. What are the reagents Reagents can be hydrogen platinum, hydrogen palladium, etc. So, let us see some examples. CH2, CH2, ethene or ethylene. In presence of hydrogen and metal catalyst forms ethane. Okay. Ethyne or acetylene. In this case, we will need 2 hydrogen, okay, plus 2 hydrogen in presence of metal catalyst will give ethane. Okay. Now, let us say we have this alkene. We have hydrogen, we have a metal catalyst. So, we get alkane like this. Okay. But why do the hydrogens join in the same side? 2 hydrogen join on the same side. Why? Now, we have to understand how hydrogenation occurs in presence of metal catalyst. So, let us say this is the metal surface. Okay. This is the metal surface. There is hydrogen. On metal surface, hydrogen gets adsorbed. Okay. Adsorption, and it becomes like this. Now, we have the alkene. Okay. We have the alkene. So, what happens? The alkene also get adsorbed to the metal surface, and this double bond becomes a partial double bond. Okay. So, this get adsorbed to the metal surface. Now, it will form like this by bonding with the hydrogen. So, one hydrogen is suppose bonded and other carbon is adsorbed to the metal surface. Okay. Now, one more hydrogen is there. So, ultimately it will form an alkane like this, and the metal surface is ready for the next adsorption again. So, we have discussed the preparation of alkanes from unsaturated hydrocarbons such as alkenes and alkynes. In the next lecture, we will study about other different methods for the preparation of alkanes. Thank you.